Hey guys, Nozilla here again. This is probably just going to be like another one of those rambling on type of videos. I promised that I'd come back and discuss a little bit more about the engine build and just the engine bay in general. So I'll try to keep this video on that topic. For right now, just like to kind of sit down and just kind of bullshit a little bit about the build. So I think I gave everybody kind of like a good overview of the whole process and how this thing started and where it is now in the previous video. But I figured we can kind of take a look a little bit more in depth inside the engine bay and kind of explain to all the little intricacies of things that are going on. So as I explained before, this was an RB25 DET Neo bottom end that was stroked to 2.9 liter via the spool 2.9 liter stroker kit. It had included all of the upgrades in that kit, including the heavy duty rods, the enlarged gudgeon pins, and the advanced ARP hardware above and beyond like your normal ARP 2000 bolts. Currently, as it sits right now, it's also running an Aeroflow extended, I believe it's an 8 liter sump. It's got the PRP block brace installed, which requires special machining from a machine shop in order to get that in. Let's see what else we got. So the head itself is an RB25 DET Neo head. It's got full Ferrea valve train in it, and it's got the Kelford, I believe the 244B cams, which are the 272 duration, and I think they're 960 lift. We have your standard, I wanted to retain VCT, so the standard Nissan, VCT cam gear, and this has been enhanced using the boost dock adjusting gear in the back. So this can be adjusted, advanced or retarded, just like any standard, like a aftermarket adjustable cam gear can be. And this is almost a necessary ingredient when you start doing anything with an aftermarket head or a machine head or aftermarket cams or anything. You need to be able to dial in this gear and zero it, more so than actually adjusting it on the dyno to make power. You need to make sure that your cams are zeroed, and that's really the only way you can do this, is by having this kit. So we have that in there. I'm running the PRP crank angle sensor bracket, as well as this is the newer version of the PRP cam trigger kit, which also mounts and holds the Kinsler 700 series mechanical fuel pumps. We have the PRP coil trigger bracket. Yes, see, there's a lot of PRP on this car. We have the Nissan R35 Hitachi coil packs with also the PRP plug-and-play harness. And that kind of ties into the entire engine harness of this car. Was completely custom made by myself. I got a Haltech premium unterminated harness, which I believe included about, I think, like 6 or 8 feet or so of line, and that was brought into the engine bay, and mapped out every part was going to be going where, and within, grouped all the wires together, wrapped everything up nice, heat shrunk all the ends, labeled all the terminal ends on the sensor plugs so they could be identified in the future. Coming down, focusing on the intake side of the engine, this is a Plazmaman RB25 Neo intake manifold. I opted to order the one without the IACV because I knew I was either going to be running an aftermarket IACV or I wanted to eventually go drive-by-wire. We'll get into that in a little bit. This is a great manifold. I know there's a lot of different options floating around for RB26 and RB25. Plazmaman certainly is pricey. But in my opinion, I mean, you'd probably laugh at me if I told you how many intake manifolds that I've been through over the course of when I started with my first R32 RB20 to now this car. But this is what I consider to be like the pinnacle of intake manifolds. And I know there's other big guys out there like CPC and Hypertune, but I'm definitely a Plazmaman fan. I also got the 6 injector unit. They make 12 injector units as well. Comes with a nice billet fuel rail, 8-in orb fitting, standard front and rear. They also give you another 8-in orb in the middle if you want to do like a dual feed, single return, or you can mount some kind of a sensor in the middle there if you want as well. Attached to that, we have the ID 1700s. Originally was going to go with 2000s. Tuner talked me out of the 2000s. Probably would have been absolutely fine, but I'm kind of anal when it comes to this stuff, and the 2000s I guess aren't specifically rated for 85. So we're the ID 1700s. So far they've been fantastic injectors. This thing idles like a champ. No issues whatsoever, and so smooth on E85, obviously. Going towards the back, we have our new Radium fuel pressure regulator / fuel pulse damper combined unit that they make, which enabled me to kind of consolidate the entire setup and have this minimalistic approach without things in the front and the rear trying to control everything. So that worked out great. I got a little Radium mechanical fuel pressure gauge that I have attached to that, which personally, I mean, you don't need these things. I also have a digital pressure sensor in there as well, which displays on the dash, but I always like to have kind of a secondary that I can look at and verify if something's not looking correct, on the dash. I can come over and look at the mechanical gauge and see if the two are corresponding or not. And then, that can be an issue over time, especially with electrical sensors. So it's nice to have the mechanical as a backup. That thing goes down underneath, in between the 5 and 6 runner with the return line, which then feeds into a Haltech flex fuel sensor, and then it goes back and returns to the tank. On the other side of that, obviously, there's a feed line coming up right next to it, and instead of going into the rail as it did before, we have it coming underneath and feeding the Kinsler. This install is almost done. Waiting on a fitting to come in for the gas tank, and then I got to remake one of the hard lines. I have to check the timing and get that back in sync with the Haltech ECU, and then I should be able to give this thing its first start, get the fuel pressure set. So hopefully I can do that tomorrow, and I'm kind of excited to show that to you guys. I mean, this is kind of a unique setup. You don't see a lot of cars with a mechanical fuel pump setup, so I've personally never seen one. The first one that I've seen, so it should be kind of fun. That's kind of the fuel system in a nutshell. Right now I'm running an aftermarket IACV as well, and I'm going to be deleting this in lieu of a drive-by-wire system. IACVs, they work nice. The factory ones are decent. The problem with them really is, though, when you get to a certain size cam, and there can be issues with idle, obviously, and IACVs can be problematic, and they're not perfect, and controlling idle is a number of different factors. And if you've ever looked at the Haltech or any other aftermarket ECU software, there's a number of different inputs, and also ways that they control the idle. Drive-by-wire is what I see as kind of like getting this thing up to date with what new tech is, and it allows perfect idle control, and it doesn't matter if you want the idle to be at 800 RPM or 3000 RPM. You set it and it goes there, it does it. There's no trying to figure out how much air it can let in versus the size of the actual line that you have feeding it. It can do whatever you need to do. Drive-by-wire's got a lot of other great advantages too, so we're going to be going that route. I'm going to make an adapter plate to fit up here that will bolt up to a Bosch 82mm throttle body, the same one that you'll find on like I think it's a 2007 to 2011 Porsche GT3 RS. So that'll be kind of fun. And then we're going to do like an adapter again. We'll get the same thing with the Vibrant HT flange on there, and it'll look nice, and I'm hoping that we can match the exact same overall length of this setup right now, so I don't have to change any of the piping, which would be fantastic. Everything else, I think I mentioned in the previous video, all the other sensors in the car are all Haltech. And again, you know, you don't have to do that. I just did it because I wanted everything to be, you know, have the name on it and make sure that everything was going to be operating 100%. That IACV is fed by a little 8N line here. And then we have our intake air temperature sensor and this titanium charge pipe right here, you know, a couple inches before the throttle body. We have an external map sensor. I believe that's a 4-bar sensor. There's a internal sensor on the Haltech unit. A lot of people use that. Some people don't. Some people use it for barometric pressure as well, in conjunction with an external. So you have the two inputs. We're gonna be running a lot of boost in this thing, so felt the need to give myself a little breathing room and to have a little bit more than I need. So we got that going on. We have temperature sensor right here. We have, this is the VCT solenoid. We also have the fuel pressure in the back. We have oil pressure and oil temperature down below. The Haltech, I think they're the Bosch style knock sensors in custom housings that I made to fit the RB blocks. Running a Tarx oil filter block adapter to run like a remote setup, and I have my oil filter down underneath here. And eventually, when this thing is fully ready for the track, we'll be installing an oil cooler. So I got to figure out routing for all that stuff and how I want it to look and where I want it to be, and there's going to be ducting involved and everything. Over here, underneath this fender, we've got fan relays. I have dual gigantic electric fans under here attached to the chase bays, tucked radiator, and they are controlled by the Haltech unit. You know, I turn them on at I think like 175 or so, and then turn them back off. I think at like 165 or something. We did with the Plazmaman manifold, welded a 20N bung onto the water neck here on the upper water neck, and it's crazy setup. You know, I had no idea this is so much different than other manifolds I've dealt with the chase base radiator in the traditional direction with the inlets on this side. There was literally no room to make a 20N line with fittings on either side. So I scratched my head on that for a while and then realized, oh, you know, just flip it around, put a little more line over here to make it happen, but it's a lot easier. I had to get a fancy vibrant, I think it's like a 170 degree fitting or something wacky like that, 160 degree fitting. And that comes over here into another 90. This goes into the upper neck here, and then goes into the radiator, and then the same thing, we return from the bottom all the way up over here. On the block itself, I have a 20N adapter, and I believe that's from a company called 26 Engineering, and they make kind of a cool product. It's a billet thermostat neck, and it's threaded for I believe 20N orbit, and you have the option of getting like a 45 or a 90 fitting on that, and I did the 45. That combined with another 20N fitting, we got it to fit nice and get it around the alternator housing and everything, and so that works out great. And the Plazmaman has got some kind of unique plumbing underneath that creates a few challenges, but nothing that we couldn't work out. There's an additional, I believe that's a 12N line underneath that goes to, there's like a water rail that runs underneath that actually has a few more external adapters to run it like you're doing like swirl pots and things like that. So there's definitely some interesting things happening underneath the manifold. And then attached onto the thermostat housing itself, and we'll also run in the boost dock heater delete, which includes the thermostat housing block, and the newer version actually comes with I think like 2 or 3 different ports, so you can run some different fittings down there for you know, either you're doing like a external head drain for the coolant, or like turbo drains, you know, turbo coolant drains, other things. So we got that, and I actually routed my turbo drain line coming up behind the cam gears here, and then underneath the turbo. For an alternator, I'm running the PRP bracket on a 200, I believe it's a 240 amp alternator, and this is made by a company that's escaping me right now. But they are OEM sized units. They fit in the OEM location. They offer a number of different variants, I think ranging anywhere from like, I think like around 120 amp all the way up to like 270 amp or something like that, like ridiculous. That's been absolutely fantastic, and I've been running a lot of, you know, complexity in my fuel pump setup and the E-fins and all sorts of other things going on, and this has been handling it without any issue whatsoever. So that's a great option. Down underneath here, I mean, for dampers, I went with the Ross Race damper. I'm not running air conditioning. I'm not running any heat. I'm not running any of that stuff. So I'm not running any power steering in the front either. So I wanted it as simplistic as possible. The Ross stuff is fantastic. Also going to be installing the Ross dry sump system into this car at some point this winter. So we got that going on, and I actually have a slightly overdriven water pump pulley to compensate for the underdriven crank pulley. With the N1 pump on here, I'm having a little difficulty with idle temperatures, and I was hoping that that would have an effect on that. And we're gonna see. I gotta get the car out a little more and do some more experimentation on that. Other than that, moving along, we have the Hypertune valve covers, which I think you've heard me talk about them in previous episodes. They're very nice. I do like them. They're very nice to look at. I would have changed things a little bit different in the design if I were the person to design them. I would have liked them to use the factory OEM gaskets for one. There's some interesting things that you have to do when you mount them, and it's not just like take them on, take them off. You have to apply gasket sealer in the front every time you take them off and on, which is kind of a pain in the butt. And then there was also some issues with the finish that I'm, in the process of getting resolved right now. But I don't think this is a factory option as far as finish goes, so I'm not holding that against them. And then it comes with the I believe they're 16 AM orb fittings in the back, and I got adapters for 12 amp lines, and we're running the least spec catch can, which unfortunately, how much I love that thing, and it absolutely looks fantastic in the engine bay. That's going to be coming out for the dry sump setup because it's no longer needed. I got a Unique Auto Creations little windshield wiper cover over there. I think that was a remnant of my other car that I brought over. Just it kind of cleans things up a little bit. Totally unnecessary, but kind of neat. This absolutely bonkers over the top Nismo titanium strut bar. Every time I open up this hood, I look at that thing, and it is just absolutely gorgeous. I freaking love this thing. Totally unnecessary, expensive, but if you're looking for like an ornament in your car, something to set it apart, that's definitely it. And since I got the titanium intercooler piping done, I figured why not, So that being said, titanium intercooler piping, 3.5 inch for the cold side with the titanium vibrant HD flange welded on to a Plazmaman race manifold underneath here. All pie cut, comes up, and then we did I think this is like a 2.5 to 3 inch inducer that we welded onto the turbo compressor housing, and then another 3 inch vibrant HD flange on that side. I am running the Borg Warner EFR9280. This is one of the Black Series turbines, one of the newer models that they have, and actually the largest model that they offer in their product lineup. This has a built-in diverter valve, so there's no blow-off valves on this car whatsoever. You're not going to get the cool kind of like fanboyish sounds that you would expect to get out of like an R32 GTR or whatever out of this engine, but in my mind, one, it's not necessary. Two, I believe this system is a lot better and more well thought out. It uses the air. Once the throttle closes, the air's got to go somewhere. Blow-off valve just blows it off the atmosphere. It sounds awesome. Instead, this takes it and diverts it back in to the turbine housing in order to, and actually directs it at the compressor wheel to keep it, to aid it in continuing to spin. So I see that as an advantage. We're using that, and there's no plans to go any kind of external blow-off valve. We did do the full race billet cover for that though, just because why not? You'll notice that I've got a Vibrant HD flange welded onto the front of the turbo. That's because I have a 4-inch titanium intake that goes down underneath the front wheel well. I'm going to be fabricating a custom air box for that at some point. That'll get fed from some portion of the bumper itself. And then also the option to run like a turbo guard or something in the front, or velocity stack, whatever, if we want to run the dyno. All the lines of the entire car, all the AN lines, they're all Vibrant PTFE lines. I've run so many different types of AN fittings and lines before, and my take on it was I got really tired of things leaking, having kind of poor quality stuff. I mean, I've run stuff from eBay, I've run stuff from Amazon, I've run cheapo stuff, I've run Russell stuff, the Vibrant stuff, I mean, you name it, Red Horse stuff, I've run it all. The Vibrant stuff, it may not be the best, but it certainly is very consistent, and I've never had any problems with leaks. I opted to do every single fitting on this car to be a full flow, non-swivel fitting. Reason being, my experience with swivel fittings is that they have an additional sealing surface, which is some sort of a rubber O-ring inside that allows them to swivel. Over time, when you subject these things to lots of heat and heat cycles, they wear out and they will leak, especially when you attach them to a turbocharger for your water lines or whatever. So if you see this car, it's all full flow, non-swivel fittings, which gives me a lot of peace of mind, just because I know that I'm not going to have to worry about those things happening. Everything else that you'll see that has a line on it that's close to any heat source, or just wanted to wrap it or whatever to keep it safe, these will be actually rewrapped as well. Has the design engineering, the DEI fire sleeves on it. Again, everything around the turbos, and very important too, lines, even if they're wrapped, whatever you do, guys, make sure that they're not touching anything hot. This stuff is only rated for non-contact. If it comes into contact, it's going to melt. You do not want your lines melting. And this is a full race twin scroll T4 manifold. It's got dual wastegate outlets on it. There's obviously a lot of plumbing that goes underneath here to control those wastegates. They are all 4N Vibrant PTFE, again, full flow, non-swivel fittings, covered in the design engineering heat wrap. Everything's been tied away, pushed back, and fastened somehow to the chassis itself so that it cannot get anywhere near the manifold runners themselves. So then we have twin Tial wastegates. Now I'm going to tell you something. So I'm running dual 39s on this, and everybody's going to look at me like, what the hell, Steve, why are you running such small wastegates? Well, I'm running a massive turbo. The plan is to run a lot of boost, and a little bit of theory behind it says that twin 39 is more than sufficient to handle it. And when you think about big turbos, you think about running small amounts of boost, you think, okay, those wastegates are going to be put to the test. And they had absolutely no problem managing this 1100 horsepower turbos, massive amount of airflow that has to bypass for a measly 500 wheel horsepower or whatever. That's when your wastegate is going to be put to the test, when you're running a low boost on a big turbocharger. When you're running a high boost, you don't have to bypass nearly as much exhaust gas because it's all going out in order to make the boost. It's all going out the exhaust. So anyways, the twin 39s, more than sufficient. And there's going to be no problem taking this thing up even higher. We do have twin external 40 millimeter screamers going down. One right here, one in the back. And then we also have a custom made titanium pie cut exhaust. The goal behind this was to, excuse me, take advantage of some, again, more theory about expanding the downpipe itself immediately behind the turbo in order to try to increase spool up. And obviously I don't have a back-to-back test for this, but the way that this turbo spools up, I'm sure that it has something to do with it. So we come right off the turbine housing and immediately have an inducer to go from the 3-inch to a 4-inch right there, and then we go 4-inch all the way down, and then where we meet up with the cap back, which is a Tomei Tiggs Bream, we have a 4-inch to 3.5-inch. So this stays 4-inch for a pretty good portion of the car, and it really its spool up characteristics. I mean, the turbo by itself is fantastic with the exhaust, everything. I mean, it's very impressive. Haltech wideband controller hooked up. You know, I think we have it about 7-8 inches back from the turbo there. I am running the Design Engineering Industries turbo blanket as well underneath here. And I don't think I mentioned before, the exhaust manifold and the turbine housing were Cerakoted in titanium colors that also have some level of heat protection as well. I do have a rear head drain. I believe it's the Franklin Engineering one. I'm going to be taking that out and replacing it with a Nitto, and doing some hard lines, especially for the rear to get underneath. Right now, I think it's like an 8-in, I'm sorry, a 10-in in the rear. And that's just, they provide a standard line there, and I want to make a nice hard line that we can fix to the block. We'll know that has no issues whatsoever with heat and everything. And I also have a front head drain up here. This is an 8-in, and it literally, I made a hard line for it. It comes out of the head and then right back down into the pan below. We're running the Kine. I think it's Kein engine mounts. They're similar to the Turbo Tough mounts. They're from a place in Russia. These mounts are at a relatively low profile, and they have a different and kind of engagement style, like a bolt through, with circular bushings rather than just like a flat piece of rubber. And my experience with them so far has been very positive. They are a lot stiffer than your standard engine mounts. There's a lot of things in this car that are definitely a lot stiffer: engine mounts, transmission mounts, and everything like that, single piece drive shaft. So there is a bit of, you know, vibration that you get in the car. It's not anything that's ridiculous. Depending on what happens with the new transmission, things may get worse with vibration. We may end up going solid mounts. I'm not sure how things are going to manage, but for right now, the car is still very, you know, friendly on the street and not too difficult to drive. Going towards the back here on the firewall, we have attached up to the T56 controlling the clutch is a Tilton, I believe it's a 3/4 inch, master cylinder with the external reservoir there. I made a hard line for that goes down to a block and then attaches to, I think it's a 3N line that goes into the hydraulic throttle bearing for the T56, and I have a Tilton triple plate metallic disc clutch down there. This is one of the 725 race edition clutches. Absolutely awesome clutch. You get these things. I never had a race clutch before. You get those things, and they're like literally they're like this big, and you're sitting there, you're staring at it, and the first time you see it, and I know this, my buddy just got one of these too, and he came to me asking the same question. You're staring at it, you're like, did I order the wrong part? Like, what's going on, you know? And because traditional clutches are almost the same size as the flywheel and everything. This thing is like 7.5 inches, and it's amazing. The pedal feel from that, coming from what I used to run in my previous car, was like a single disc. I think it was a 6-puck sprung disc, ACT street strip, and that thing was an absolute bear to press down with your foot, and consequently I ended up breaking the welds on the clutch pedal bracket, which is, I guess, a pretty common thing for the R32. It's very weak, so you either get a Nismo bracket or you reinforce the spot welds. So I ended up making the hard line anyways, because I found an incredible amount of expansion in the soft lines, and I was having difficulty even getting engagement. So once I went to the hard line setup for that solved everything. I am running no brake booster in this car. I didn't run a brake booster in my previous car. It's certainly a different driving experience. It takes a bit to get it used to, but it's nothing that you can't do. It's something that you can still certainly daily drive. Just gotta be more aware of it, and you gotta leave yourself a little bit more time, a little more reaction time for driving on the street, that is. But the pedal is a lot more consistent. certainly requires more effort, but it is a lot more consistent. There's no surprises. If you're running big cams, obviously you're not going to have a lot of vacuum. So at some level you make the decision where like maybe the brake booster isn't really needed, it's a waste of space. Having it in there certainly takes up a lot of space in that area and prohibits you from really accessing back behind the manifold. So removing that, there's plenty of space now to actually get your hands in and work underneath the manifold, which I personally find a lot more beneficial. Also next to that in the back we have, I brought up a 12 volt distribution block there with 0 gauge wire, and then I have hard lines going to the starter and the alternator. I'm not sure I mentioned, I told you I wasn't running a brake booster, but so I'm running the Chase Bays delete kit. And this current version I am a lot more happy with than the previous version that I had, which seemed to have some quality control issues, but this one seems to be very nice, so that is definitely cool. We are running a 3-port boost control solenoid. Again, your standard Mac valve. This is a Haltech unit. That's all plumbed in 3 MPTFE again. I think that kind of is about it for the engine bay. Not sure if I missed anything, but there's some other cool stuff up here too. We have the 78 Works R32 headlights. Absolutely fantastic. I love them. Huge upgrade. If you drive your car on the street and you're driving at night, the OEM headlights are not up to the task. And if you got money invested in your car, you definitely don't want to be hitting deers or not being able to see at night and having something happen. So I like this as a safety upgrade. So I would definitely suggest that. This is a Sieben DVI2 carbon fiber hood. Again, this came from my last car. It's not in the best of shape. It's got a few, spider cracks in it and stuff, and it's been beat on a bit. It's dropped, a couple times, but there's no plans to change it. It's still a great hood, nice and light. We did the aero catch latches, and we got them into the radiator crossover bar here. And we did, I think they're Maori, I believe it is the hood struts. These have been great. I had the Tyne ones before. They were good too. These ones seem a bit more heavy duty. Got them from Right Hand Drive Japan, and consequently they're also wrapped in like a carbon fiber, so it kind of matched the engine bay a bit. On this side over here, we're not running a 78 Works. We're running the Motive DVD carbon fiber headlight duct. And that thing is just an absolute animal, and letting air into the turbo, and obviously turbo here, duct here. So that's was a nice setup. I'm definitely going to enjoy that on the track. Radium radiator cap. We have a Chase Bays overflow over here, and I think that's it, guys. If you have any questions specifically, leave them in the comments, and I'll try to address them later. If not, we're going to move on to the mechanical fuel pump, FPD, FPR, and the mechanical external FCSD, for the next video. Probably going to do like a good explanation for that and do like a time lapse on the install and stop on a few things. We can show you a couple tricks in case you never installed an FCSD into a tank. It can be a bit of a bear unless you know what you're doing, so I got a couple tricks there. And also took a moment to inspect the fuel filter. So we'll take a look at some of these things. Until next time, guys.